long as YouTube doesn't pull down the video with my own song in it. We'll see how that goes. That was fun. The video that you guys had to watch for the last grade one, that's my song that I wrote for my band, and YouTube sent, did I tell you about this? YouTube sent me the note about, yeah, they haven't pulled it down yet, have they?
No.
Yeah, I'm still waiting for that. That's going to happen eventually, and I'll have to resubmit my appeals.
I'll flag it for you.
What's that? You'll flag it for me? Thanks, appreciate that. So, yesterday, Monday, it was a beautiful day outside. Today is another beautiful day outside. I apologize for being in here. But now it's time to understand when you're going down the highway and you see the policeman on the side of the road with the hairdryer pointing at you, it's time to understand what the hairdryer is doing. Yes, it's time to understand how a speed gun works. That's what today is all about. Today is all about understanding the speed gun slash hairdryer slash magic box that the police point at you, and it's also to be educated if you ever have to go to court to contest a ticket, to be able to understand what is going on. This has actually worked for me once in my life. I got one speeding ticket back in Delaware, and I asked them, the calibration on the machine, when was the last time it was done? And the policeman couldn't tell me. And I'm like, well, how do you know it's calibrated correctly? And you'll see why that's going to make a difference when we start doing our calculations. Calibration on the calculation that gun is doing, this was 1991, 1990 or something like that. And police now realize that those things have to be calibrated constantly in order for it to give an accurate reading. And you're about to see why an uncalibrated hairdryer is not a good thing for a speeding ticket. So anyway, I'm getting ahead of myself, a speeding ticket. I had some questions up last time. I've since forgotten them. Hopefully you don't. Remember, we had some guesses to my speed when I crossed the 200-foot tape. I forget them. How fast was I going?
Fast.
Give me a number, if you would.
13.3.
13.3 miles per hour. Holy crap, oh thank you. 13.3 miles per hour. Other ones? 8. Did you already calculate it? Nice. 8. 10, 20. Good. And so forth and so on. We had a few on the board last time. What I want to do is I want to figure out who's closest. Who's closest to how fast I was actually going when I crossed that 200-foot tape measure. So, if you would, call the data back up from yesterday. Hopefully it's still in your TIs. I don't think you didn't have to use your lists for the exam at all, so hopefully you didn't erase that data. You did?
On accident.
Well, hopefully you used other lists. Oh, you cleared them on accident. I got you. Well, that's okay. We'll get them back. I left mine. Let's push this over here. I left mine. I think I put them in L1 and L2. I left them there. Nope, they're gone. But, nope. This is strange. Mine are gone as well. I'll have to call them in from Excel. So if anybody else lost them, apparently I did too. Which is strange. Oh, I know why. Because I ran a program yesterday. Hang on. I ran a program which cleared the lists. If anybody needs the data, I'll put them back up on the screen here. And then you can re-enter them. My apologies. Quadratic modeling. Rolling bike.
Oh, okay. Cool.
So the data we agreed on is right here. So we'll go L1, L2. Just take a few moments. Okay, so now it's there. Okay, so everybody, people in this room, I just had this on. Did you not see L1 and L2 blank? Mm-hmm. There's nothing there. It is now there.
Weird.
Okay, so what the hell? Okay, and it's on video. What the hell just happened? Okay, 30 of you watched it happen too, yes? It was not there. I turned it off, turned it back on, and it came back. Seriously, what the hell?
Did it reset itself?
If it reset itself, it'd be gone. A little freaked out right now, I'm not going to lie to you. Anyway, if you need the data, there it is. I'm going to try to figure out what the hell's going on. There's your data. It was all gone except for L3 and L4. You saw that. Yeah, and that wasn't even the same, and there wasn't anything in L5 or L6. Because you see what I did? I copied my data over L5 and L6 to make sure I didn't lose it. This is freaking me out. Whew. Yeah.
Still is Twilight
So anyway.
It's still Twilight Zone. Sorry, go ahead, Michelle.
So we're putting a point?
This is your times. These are our times. These are our distances at those times. That's what we're going to analyze to figure out my speeds at various places along the way. And we like this as quadratic modeling, not linear modeling. Remember as you guys are, why do we call this quadratic and not linear?
Because it fits the graph.
Oh good, it fit the graph better. Very good answer. Well, as we looked at as we looked at how much distance I was covering versus time, there was not a consistent ratio for time elapsed and distance covered. As a matter of fact, it took me about 3.4 seconds to go 25 feet. But then it took me about 1.5 seconds to go the next 25 feet. And then it took me less time to go the next 25. And on average, it was taking me less time to go the same distance, which means I am accelerating. Good use of the word accelerating. My velocity is changing. The difference between linear and quadratic modeling as far as speed goes is linear, you'd be going the same speed from start to end. Like imagine walking. Generally, you're going to walk at roughly the same rate over short distances. Quadratic representation of speed would mean that your speed is either increasing or decreasing in a predictable way. Again, in a predictable way. That's also the idea of quadratic versus linear. We also tried exponential. That was a good vote last time. Why didn't exponential work? Remember?
The domain.
We got a domain error. That was quite nice. Remember why we got a domain error on that one?
Yeah, 0, 0.
Okay, 0, 0 was a bad thing. In case you don't like why 0, 0 was a bad thing, we'll come back to it later. I want to take a pause here, and friends, if you're getting the data back in, there are 2 more data points you want to get down here at the bottom. I want to do a real quick aside, and come back to this messy data. This is not perfect quadratic data as we saw yesterday. We're going to refit the data here momentarily. It's not perfect quadratic data. It's quadratic-ish, and it's quadratic enough-ish. We learned why, and why is it quadratic-ish enough? What force is acting on me on that bike? Predominantly. I wasn't pedaling. The predominant force was gravitational, and the gravitational laws show that it's quadratic. Exactly. Show that I fall. We fall. Things fall on Earth as a distance is a quadratic function of time. That's just, it's one of those laws that we operate. Gravity is a function of mass, but the distance we fall, if left to free fall, is governed by the square of the time that you're free falling. And I wasn't free falling. That'd be fun. I wasn't free falling. I was going down a hill, but essentially gravity was the only thing pulling me down that hill. Everything else was fighting the going down the hill. So real quick, I want to take a pause. I'm going to leave this up in case you need it. I'm going to swing over here, and I want to look real quick at a general quadratic model versus a linear model. Real quick.